Okay, in this problem, Walter is going bowling with a couple of his friends. So let's draw Walter here. And one thing you should know about Walter is that he will sometimes bring his Pomeranian with him in a carrying case. So there's this Pomeranian, and it's actually not his Pomeranian, but you know, he's just watching it. He takes a bowling, and so here's the bowling alley, maybe there's a bowling ball, and then a bowling pin. Really big bowling pin. Okay, and we know a couple of things here. We know the length of the bowling alley, so let's say this is D for the length. And they tell us here that it's 19.2 meters long. Okay, and we also know that the ball strikes the pins, and Walter hears the sound of the ball hitting the pins 3.1 seconds after he released the ball. Okay, so the ball travels down the lane. Let's call the time it takes to do that T1. So this is time for ball to travel down the lane. And then what happens? It hits the pins, and then you hear the sound travel back. So let's call that T2. And this is the time for the sound to travel back. So what is this 3.1 seconds? Well, that's the total time. So I'll call that T. And T is T1 plus T2. So when you add the times together, and that is 3.1 seconds. Okay, and then we also know the speed of sound. So let's say that the speed that the ball travels at down the lane is V1, and then V2 is the speed for the sound to travel back. So this is what we're trying to find. We want to know how fast the bowling ball was traveling. And then V2, the sound speed, is 343 meters per second. Okay, so now I think we're ready to write down some equations. So we're looking for how fast the ball was traveling. Okay, so, well, I know that V1 is related to D over T1, and I know that V2 is related to D over T2 because the speeds are constant for both the ball traveling down the lane and for the sound traveling back, so I can just use the simple rate equation. Okay, and I'm looking for V1. Okay, so V1 is D over T1. Now I know D. I don't know T1, but I do know that the total time is T1 plus T2, which is 3.1 seconds. So maybe I can solve T1. I can write this as T minus T2. The total time minus T2. And then T2, I know from this equation. So if I were to plug that in here, so that would be T minus, and now T2, if you solve this for T2, so here I'll do it right here, T2 then would be D over V2. Okay, so let's plug that in here. So that would be D over V2, and then it's still all under D. And now to get rid of this compound fraction here, let's multiply everything by V2. So I get V2 T minus D, and then I get a V2 D up top, and I'm ready to plug in because I know all these things. Okay, so let's do it. So I'll do it down here. So, okay, V2, that's 343 meters per second. And then the total time is 3.10 seconds. Minus the distance, 19.2 meters. That's my denominator. And then my numerator, V2 is 343 meters per second. And the distance is 19.2 meters. And if you do this on the calculator, you end up getting 6.31 meters per second. And that is the speed of the ball.